everybody. We're getting ready to do lesson 9.3 part 1 for grade 6 math today. And for 9.3 part 1, order of operations, you got 37 points here that goes on your classwork sheet. Have that out in front of you. And then 6 points will go into your notebook. Have that out, or your notebook guide. Name, date, period. Here's students' due date for onliners, homeschoolers. And let's go right into our bell work here. Students and teachers, find the product of these students, both up here, down here. Teachers, give your students about 3 minutes to do this. They should really do this quickly. So check back in 3 minutes. Okay, welcome back for our answers here. 7 times 7 times 7 is 343. And then for number 6 here, 3 times 3 times 3 times 3 would be 81. I think we did that in the previous, so you should know that. Down here, 6 times 6 times 6 times 6 would be 7,776. And then for number 8, 2 times 2 times 2 times 2 times 2 times 2 would be 64. So that's what you should have, students. Now into today's lesson, we're going to start out with an essential question. How do you use the order of operations to simplify expressions with exponents? Would be the question there. And then we'll have an explore activity that will explore that as well. And we're going to explore the order of operations. So get ready for that. Here we have a notebook entry in here, students. This is 4 points going to your notebook. Number 1, perform operations in parentheses. 2, find the value of numbers with exponents. 3, multiply or divide from left to right. Now this is your order of operations, 1, 2, and 3. And then 4, add or subtract from left to right. So this is very important here. This is your order of operations, first, second, third, and fourth order of operations. So let's try an example here by using the order of operations. Amy and 3 friends launch a new website. Each friend emails the web address to 3 new friends. These new friends forward the web address to 3 more friends. If no one receives the email more than once, how many people will receive the web address? In the second wave of email. So with this kind of like situation here, what will we do to solve that? So we're going to use a diagram to model this situation for Amy's website up here. So Amy, first wave of her send-outs of her emails, she emails 3 of her friends like that. Complete the diagram to show the second wave. So here's the first wave. Here you got 3. And then the second wave of each one of these friends emails 3 other friends. You got 3 more here, 3 more here, and then 3 more here. So how many people on the second wave do we have, plus the first wave? How many people will receive the web address in the second? Okay, so this is our answer down here. So how many people, students? Complete the table to show how many emails. So first wave, second wave, number of emails, power of 3. So we have a power of 3 here. So the first wave, how many emails are sent in each wave of Amy's diagram? So the first wave, we had 3 emails, right? When the first wave had 3 emails. And then remember, here's Amy's first wave, 1, 2, 3 on the first wave. And then the power of 3 will be 3 to what power, students? It will be 3 to the first power for the first wave here. And then the second wave, we did, each one of these friends did 3 of their friends. So to do that, that came out to 9. So what power of 3 is 9? It would be 3 squared. Okay, so now that we know that we have a total of 9 in the second wave, Amy is just one of 4 friends initiating the first wave of emails. Write in an expression for the total number of emails sent in the second wave. So Amy was just one of 4 friends. What about if you add her other 3 friends? The number of people times the number of emails in second wave written as a power. So number of people times the number of emails in second wave. So how many people did we have emailing 3 of their friends? That would be how we would find how many total number of the 4 friends in the second wave. What would that be, students? So the second wave is a power of 3. We knew that. And we got 4. We got 4 friends here. And then what did we have in the second wave? We had 3 to the second power. So 4 times 3 to the second power, how many? Identify the computation that should be done first to simplify the expression in C. Then simplify the expression. So multiply 4 and 3. The value of the expression is 4 times blank equals blank. So what do we have? Multiply 4 and 3, but powers of 3. Find the value of 3 squared. So what's the value of 3 squared? It would be 9. So 4 times 9 equals what, students? Equals 36. So there was a total of 36 people that were emailed in the second wave. Simplifying numerical expressions. So a numerical expression is an expression involving numbers and operations. You can use the order of operations to simplify numerical expressions. So we're going to get back here to our order of operations. Example 1, part 1, simplify each expression. So we have 5 plus 18 divided by 3 squared. So which operation do we do first here? 5 plus 18 divided by 3 squared would be the same thing as 5 plus 18 divided by what? What's 3 squared? Evaluate 3 squared. Your 3 squared would be 9. So remember, the first number 1 order of operations would be, well, actually number 2 would be exponents. 3 squared would be exponents, and 3 squared equals 9. So 5 plus 18 divided by 9. So 18 divided by 9 would be 2. So 5 plus 2, add, and 5 plus 2 equals 7. So by using the order of operations, we know when you simplify this expression, it would simplify to 7. Let's try another one here, part 2 of example 1. Simplify each expression again. 21 plus 3 squared over 3. So how would we simplify that? 3 squared, 21 plus 3 squared over 3 would be 21 plus 9 over 3. So what's 9 over 3? 9 divided by 3 is 3. So 21 plus 3 would be what? 21 plus 3 would be 24. So this, when it's simplified, would be 24. You add. And that is your 9.3, part 1. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.